All right, students, welcome to Chapter 6, Reliability and Validity. Chapter 6 is the last chapter that will be covered before we take the midterm next week. So next week's midterm will cover chapters 1 through 6 and everything we've talked about in the first 5 weeks of the semester. So if you think about the name of this course, Health Science 349, Measurements and Statistics. Throughout the 16 weeks of the entire semester, 2 of those weeks is your midterm and the final exam, or the final review. The other remaining 14 weeks are all about content. But really, of those 14 remaining weeks, 13 of those weeks are all about learning about statistics. That 1 week, this week, is about learning about measurement. You'll learn much more about measurement when you take your Health Science 475 Research Methods course. But really, this is going to be your first introduction to thinking about measurement, thinking about how do we measure what it is that we want to measure based upon the research study that we want to do, or a research problem we want to figure out, or a question that we want to figure out. And so being able to say, I want to see smoking behaviors, and I want to see heart disease, cases of heart disease. How are you going to measure these things? This is the idea behind measurement. Reliability and validity are just two properties of measurement that help us determine how well a specific tool, instrument, questionnaire, device is in terms of measuring what it is that we want to measure. So the objectives of this chapter are to know what reliability is and what validity is and why they are important. You also want to know how to compute and interpret various types of reliability coefficients. So we're going to learn about 4 different types of reliability coefficients. In your textbook, it goes over calculating specifically what's called internal consistency, or Cronbach's alpha. That's one of our reliability coefficients. You do not have to learn how to hand calculate Cronbach's alpha. However, the other 3 you will have to calculate. They're relatively easy ones, as you'll see. We'll also learn how to interpret our reliability coefficients in terms of whether or not our instrument tool is deemed reliable or not. And then we'll talk about different types of validity and how to establish these types of validity. When we talk about validity, there's no calculations, it's all conceptual. It's all how do we validate what it is that we want to measure when we create our new measurement tool. All right. So let's start off with the first part, reliability. Reliability is really whether a test, an instrument tool, whatever it is that you're using, measures something consistently every single time you use it. Is it going to measure what it is that you want to measure? Right. When you think about reliability, it's consistency. One day you try to do it, the next day you try to do it, different types of things, does it measure it every single time? This is reliability. Before we talk about the 4 different types, I want to make sure we kind of talk about something else real quick. This whole idea of test scores. We have observed scores. So think about what you earned on quiz 1. Quiz 1, let's say you earned an 89%, or you earned a 65%, whatever it is. This is what you actually earned. This is your observed score. However, let's say you totally forgot that you had the quiz and you had to take it, and you were rushing and you only had 30 minutes to take the quiz because you procrastinated or you forgot, but you really knew the material. Your true score would be a 100% accurate reflection of what you really know. But because you procrastinated, or because you forgot, or because you weren't feeling well, whatever it is, something external may have caused you to not do so well. This is your observed score. So we have this differential. We have this difference between what you actually do know, your true score, compared to what you actually earned, your observed score. And rarely are these two scores ever going to be equal, because unfortunately, there's no way that we can ever really, truly know what you really know based upon testing you, right? If I give you its test right now, there may be something that's going to throw you off. You maybe don't have a calculator. Maybe you feel anxiety all of a sudden, so that stress overwhelmed you and you did poorly. So your score the second time around is still not a true reflection of what you really know, because it was kind of a pop quiz, and that stress and anxiety, that fear came over you. And so this thing that causes a difference between our true score and observed score is really our error score. The difference between what we really think we really know and what we actually know we know compared to what we earn. And again, different things may cause the differential, your error score, such as temperature of a room. Maybe it was really, really cold, you didn't have a jacket, you were wearing shorts, flip-flops, and you were just so cold that you couldn't focus, and you did poorly. Or maybe you got into a car accident, or you saw a terrible car accident, and you had a bunch of traffic, and you were running late, and you were completely frazzled. All of these things are outside conditions, different things that are going to impact how well or how poorly you do. And so, keeping this in mind, there are 4 different types of reliability in terms of how consistently does our measurement tool, does our instrument measure what it is we want it to measure. So the first one, test, retest reliability. This is a measure of stability of the test over time. Let's say I give you a 5-question quiz. Give it to you today, I give it to you next week. Without any intervention, without you studying before either one of those time trials, we would think, and you would hope, that what you earned on the first time is going to be pretty much relatively close to what you earned on the second time. So when we think about test-retest reliability, it's 2 different time points, and whether or not the results from that instrument that you use, your measurement tool, whether or not it gives the same results time and time again. Parallel forms. Parallel forms, essentially, if you have 2 different types. So let's say you're sitting in my class. Instead of taking this course online, you're taking it in person. You'll have a pink copy, test A, or you may get the green copy, test B. They're both the exact same questions. Maybe they've moved around, maybe they're different numbers, maybe they're multiple choice, maybe in test A the answer would be A, but in test B the answer is going to be D. Switch around the numbers. But really we want to see whether or not test A and test B measure how well you know the content. But it wouldn't be fair to say that, well, test A is going to be really, really hard, and test B is going to be really, really easy, and then good luck to you, whichever one you get, see how well you do. That's not going to be fair. There's no equivalence in terms of whether or not they both measure what it is that we want you to know. Internal consistency, yet the 3rd type of reliability measure. Internal consistency reliability coefficient is also known as Cronbach's alpha. Cronbach's alpha, internal consistency, is really when we're thinking about a scale. Let's say we have 5 different items, and these 5 different items measure mood. Do these 5 items all together really measure mood? Or do we need to add more? Do we need to take some out to see whether or not these 5 questions, or maybe less or maybe more, is going to be a better measure of mood? And then the last type of reliability, inter-rater reliability, the measure of agreement among raters. Let's say we had 5 students, and I asked the 5 students, okay, I want you to sit out on Titan Walk, and I want you to observe these first 10 students that walk by in front of us. I want you to see how many times these people look down at their phone and document it. Well, we're going to have at the end of these 10 students that walk by, each of the 5 students who are collecting the data, who are observing these 10 students and documenting how many times they look down at their phone, we would want to see how much do these 5 research assistants, or these 5 students collecting the data, agree upon what they saw for those 10 students walking on Titan Walk. So we're going to go into each 4 of these into much more detail right now. So don't worry if you're still a little confused about what I was saying or what these mean. We'll see it in more detail.